to do this. So here we go. Practice quiz question number 1. It's one of these tables showing the probabilities, the frequencies of, what do we got, colored beads. Okay. So let's see how many of these questions we can answer. We got Olivia and Thomas. We have green, blue, and yellow beads. And let's make sure you all understand what this chart means. This means that Olivia has counted the beads in her bowl. She has this bowl of colored beads, she's counted them. 40% of them are green, 30% are blue, and 30% are yellow. And then Thomas, likewise, these are his percentages. Okay? So one bead is chosen from each bowl. So I'm going to take a bead out of here and a bead out of here, just one. A says, what is the probability that both will be blue? Okay, so here's Olivia's bowl. What's the probability I'll get a blue one from Olivia? 0.3, 30%, 0.3. Now I'm going to pick one out of Thomas's bowl. What's the probability I'll get a blue one from him? 0.5. Now what do I do with these two numbers? I am getting a blue and a blue. Multiply. When you are doing X and Y, Olivia and Thomas, you multiply. Let the calculator do the work so you don't mess up your decimal points. It's 0.15. Now that is a probability, so you're welcome to write it as 0.15, but you could also say 15% if you wanted to do that. But you're welcome to leave it as 0.15. All right, B, what is the probability that neither are green? So that means I'm going to Olivia and I don't want a green one. So what's the probability I won't get a green one from her? 60.6. Now I'm going to Thomas. What's the probability I won't get a green one from him? 0.8. Again, I want not green and not green, so I'm going to multiply those together, 0.48. Now I want green and yellow. Right? I want a green one and a yellow one. This is a little tricky. Because does it matter who I get the green from? No, as long as I get one green, right? So I'm actually going to have two problems to do here. I'm going to do Olivia gives me green, so that would be 0.4. And Thomas gives me yellow, that would be 0.3. So that would be 12% for Olivia green and Thomas yellow. But could it be Olivia yellow and Thomas green? Yeah. I just need to end up with a yellow one and a green one. I don't care where they came from. That's what I have to end up with. So Olivia yellow would be 0.3. And Thomas green would be 0.2. So that's 0.06. Now listen to me. I need green and yellow, or I need yellow and green.
You add them.
I add them. These are two separate problems. I'm not doing them together. I'm saying, okay, I want green and yellow. There's a 12% chance of that. Or I want yellow and green. There's a 6% chance of that. So the total probability is 0.18. Everybody got it? Think there's a problem like that on your quiz tomorrow? Yeah, pay attention. Pay attention. All right. Number 2. Ferris! We're going to expand. So we're going to expand x plus 3y to the fourth. So Olivia says this is a 4. So I got to start with a string of coefficients, and that string of coefficients is going to be the 4th row of Pascal's triangle.
1, 4, 6, 4, 1.
That is exactly what it is, but most of us probably don't have it memorized, so we'll have to put it over here in the corner. Certainly if you have it memorized, that's great, but most of us don't. So we start with a 1 and a 1. We put a 1 on each end. Then what's going to go here?
2.
2. We put a 1 on each end. What's going to go here?
3.
1 on each end. This is the row I want. So I'm going to be able to stop here because this problem just says I need the 4th row. So what'll go here?
4. 6. 4.
So Olivia said you need to write down the numbers 1, 4, 6, 4, 1, and she was exactly right. Now what? Now we look at the problem. So this tells us which row to go to, so we did that already. Now we look at these, the 2 individual components of the problem. This is binomial expansion, so there's going to be 2 parts of the problem, and we write down each piece in parentheses. We're not going to be lazy. We're going to write down each piece in parentheses. So every one of those coefficients, the 1, 4, 6, 4, 1, every one of those is going to have an x and a 3y next to it. Yeah, at some point, it doesn't have to be right at this minute, but at some point, you need to make sure that your terms are separated, because we are eventually going to be simplifying, and when we simplify, we have to do it term by term. So these things get real cluttered and crammed together, so you want to make sure you're separating them, always with plus signs to distinguish which term is which. But there's one more thing. What was the other thing you said we needed to do? Exponents. And to put the exponents on, we go back to this, right? And then on the x part, the first part of the problem, we start with a 4, and then go down, and we should always end up with 0. And then we go backwards the other way with the y's, so that we end up with a 0 again. It's just counting. Now this is essentially the answer. All we have to do now is simplify it. So here is the first term. That is a multiplication problem. Everything in there is times together. So what happens when I multiply all that together? All I get is x to the 4th. Remember, anything to the 0 power is 1. So this, right here, this is all just 1. All right? So now I'm on to the next term. Everything here is multiplied together. You are multiplying. So what do I end up with? 12x cubed y. Everything here is multiplied. Watch it, watch it, watch it, watch it, watch it.
18 x squared y squared.
24. 18 y squared, 24. 24.
I heard somebody said it finally. 54. It's 54 x squared y squared. Boys and girls, see this right here? That squared applies to the 3. What's 3 squared? 9, which has to be times by the 6. So 9 times 6, you got a calculator if you need it. It's 54, x squared, y squared. Okay, Magnus, wake up please. What's the next one? We're multiplying all that together. So what's that going to be? That's a 108.
108
X, y cubed.
yeah.
It's 108 because 3 cubed is 27, and 27 times 4 is 108. You have a calculator. And then the last term,
81.
this is just 1, right? So we can kind of ignore that.
81.
So 81 y to the 4th. And this is your final answer. Okay, that's the final answer. So just to recap, there are just a few steps to this problem. How did we start it? What did we do first?
Right off the Pascal triangle.
Yep, write out the row of the triangle, and you know which row to use by that exponent, right? I'm not going to give you like to the 10th power or something. It's going to be a small number like this. So you write out the numbers. Then what? You attach these. Make sure each term is separated and put in your exponents. And then just multiply. Is that good?
Yep.
All right. Number 3, how many ways can the letters of statistics be arranged?
So you have 10
Beta.
Okay, there's 10 of them.
divided by 3.
Beta.
All right, what have we got? We have 3 S's.
3 S's, you have 3 T's.
We have
And
3
2
T's.
And 2 I's.
2, oh my goodness, 2 I's. And that's it, A and C. So this is what I'm going to type into my calculator, making sure that the denominator is in parentheses.
50,400.
Oh, yeah.
You already have it?
50,400.
Yep, 50,400 is right. 50,400 ways to arrange those letters. Everybody okay? How many ways, this is number 4, how many ways can I arrange 8 dolls on a shelf? 8 factorial. So problem number 4 is 8 factorial. And 8 factorial is 40,320. So the answer to number 4 is 8 factorial, which is 40,320. So there are that many ways to arrange 8 dolls on a shelf. All right, number 5 is a Venn diagram. And we got Fords and Buicks. And we have surveyed 20 people. So how many like Fords? How many like Buicks? Everybody's voted. We tabulated it right here. So the question is, how many people like Fords?
13.
13. So the answer to A is 13. When we said, raise your hand if you like a Ford, 13 hands went up. How many people like only Buicks?
6.
These guys right here, those 6 people like only Buicks. How many people don't like either?
1.
And you know that because you've got a total of 19 in here,
Yeah.
but there were 20 people surveyed, so there has to be one guy out here that doesn't like Fords or Buicks? E, or E, 6. How many committees of 3 can be formed from 50 people? Now, this is either going to be 50C3 or 50P3 because you have 50 people and you are picking 3. Which one is it? C. It's got to be C. There's no order. We're picking a committee. If I said to you guys right here, I'm going to pick a committee of 3 of you to help me go decorate the faculty lounge. Does Ian care if I pick him first, second, or third? No, he just wants to go help me decorate the faculty lounge. Order doesn't matter, right? But if I said, I'm going to pick 3 of you, and the first one I pick is going to be the president, then it matters. But if I'm just picking a committee, it does not matter. So 50C3, anybody got that typed in yet?
19,600.
9,000? 19,600?
Yeah.
How many outfits are possible if you have 12 shirts, 8 pants, and 3 shoes?
Multiply them together.
Multiply them together, and what do we get? 288? Is that right?
Yes.
That's tomorrow's quiz. All right, so of all the problems on tomorrow's quiz, 7 of them it looks like, is there any one you're going to miss?
The expanding one.
All right, let's do one more expansion.
Shut up. Shut your face.
Ferris, we're going to do an expansion. Which one did you just? Okay. Olivia, you with us?
Yep.
Thank you. All right, so here we go. We're going to do this expansion. Go! You guys, seriously, you have like just a couple more days to enjoy my presence. Come on.
I know how to do it.
All right, here we go. Step 1. We're going to go to the 5th row of Pascal's triangle, right? So I shouldn't have erased it, but I did, so I have to start over again. So I start with 2 1s, then a 1 and a 1, and in the middle will be a 2, and then a 1 and a 1, and in the middle will be a couple of 3s, and then a 1 and a 1, and in the middle will be 4, 6, 4. And now that's 1, 2, 3, 4. I gotta go one more. So 1 and 1.
5, 10, 10, 5.
5, 10, 10, 5, and then 1 more for those of you that can't see it. Okay? So there's the 5th row. So those are the numbers I'm gonna write down. So I'm gonna write down 1, 5, 10, 10, 5, 1. All right, what's the next thing I'm gonna do? 2x and y next to each one. Things are starting to run together, so I'm gonna put my plus signs in to make sure that I don't get confused. I want to separate these terms, so I'll put some giant plus signs in there to make sure that my terms are separated. The last thing is the exponents.
Yep.
So I'm going to start with a 5 right here.
Yep.
And count down. Remember, you should always end up at 0. And then the other way. And another little check, if you care, is see all these, each pair adds up to 5. That should happen. All right, so let's simplify. Here we go. What's this first term? Remember, anything to the 0 is 1.
32.
32 x to the 5th. Very good. 2 to the 5th. 32. Plus, now I'm timesing all of this. What's that right there?
16.
That's not it.
X4.
That's 16.
That's 16.
2 to the 4th. 16 times 5. 80 x to the 4th y. Now all of this, what's right here? That's an 8 times a 10, another 80 x cubed y squared. Kaufman, this is making sense? All right, now we got this one. What's this one gonna be? 40 x squared y cubed, because that's a 4, 2 squared. That's just a 10, x y to the 4th. That's just 1, so the last term is just y to the 5th. Got it? Anything else of those 7 problems that we might miss?
So that's it, we don't have to simplify that?
That is simplified. There's nothing else you can do with this.
That's the final answer.
That's the final answer. This is the final answer. It is completely simplified. All right, so the Caroline?
The first one.
All right, so we're going to have a table. And Caroline and Stephanie they're making necklaces with their colored beads. And they have gold beads and blue beads and green beads. And Caroline has counted and she has 10% gold. She has 20% blue and 70% green. Stephanie has 60% gold, 20% blue, and 20% green. Okay, so that's the given. You don't have to do that. That part's given. And then the questions we're going to answer is, we're going to pick 2. Choose one of each. So we're going to pick a bead out of each girl's bowl. And we want to know what's the probability of both gold. What's the probability of neither blue? And what's the probability of gold and green? Okay, so those are the questions. All right, so here we go. What's the probability they will both be gold? 0.6, or 0.1, sorry, 0.1 for Caroline, and 0.6 for Stephanie. And since I want gold and gold, what do I do with those numbers? Multiply them. So I get 0.06. So the answer is 0.06. All right. Now, neither blue. So what's the probability of no blue from Caroline? 0.8. And no blue from Stephanie? 0.8. So that answer is 1.64. Now I want to get a gold one and a green one. This is the tricky problem. Because where does the gold one have to come from? Either one, right? So I got to do both cases. So I'll do gold and green first. Okay, so gold and green, let's see, gold would be 0.1 and green would be 0.2. So that's 0.02. Then I got gold from Caroline and green from Stephanie. but I could have gotten green and gold. So green from Caroline is 0.7, and gold from Stephanie is 0.6. That's 0.42. And I add those up because it's this one or this one. They're both okay. Either one's okay. So I add them up, and the answer is 0.44. Right? Anybody have any others on here that we want to talk about in our remaining couple of minutes? Okay, so tomorrow when you come in, we're going to take the quiz, and then I'm going to hand back all of your, we got a couple of tests yet that I haven't handed back. We're going to get those handed back, and then we'll start exam reviewing if we have time to do that. Okay? Everybody got my email and read it about our study session?